Servicing the DUO-THERM furnace. The DUO-THERM furnace is now standard equipment in the GMC Motorhome. Besides being quieter, there's less temperature fluctuation with this furnace. In addition, it has fewer parts than the furnace used previously, and it takes a lot less time to remove it from the vehicle for service. It uses a solid-state direct spark ignition system. There is no pilot light, no air adjustment, and no manual lighting required. The furnace features a sealed combustion system. That is, air for combustion is drawn from outside the vehicle, then returned outside. Air inside the vehicle is drawn through the front panel of the furnace, heated as it passes around the heat chamber, then forced by a blower through heat ducts to the vehicle interior. An auxiliary blower behind the kitchen range boosts heat flow into the bathroom module. Whenever the furnace is operated, there are two important precautions to keep in mind. 1. Keep the window above the furnace closed to avoid the possibility of drawing carbon monoxide from the outside vent back into the vehicle. And 2. Move the vehicle outside your shop during initial furnace startup, or when checking furnace operation after you've repaired it to be sure of adequate ventilation. Now let's look at the main components of the furnace and how the system works. There's a manual gas valve on top of the furnace. It must be fully open for the furnace to operate properly. The gas control valve on the front of the furnace is a combination manual shutoff and pressure regulator. A pressure regulator on the furnace is a federal requirement. This is in addition to the gas pressure regulator valve on the LP supply tank. The gas solenoid valve controls gas flow to the combustion chamber. It opens and closes in response to the thermostat. The limit switch is a safety device. If the furnace gets too hot, over 200 degrees, it opens the electrical circuit to the solenoid valve, thereby shutting off the gas to the burners. The fan switch controls the operating sequence of the furnace blower. You'll hear it snap closed when it heats up after about 1 minute of furnace operation. When the thermostat is satisfied and shuts down the burners, the fan switch allows the blower to keep running for a short time. When the combustion chamber cools, the fan switch contacts open, shutting off the blower. The blower assembly has one motor that drives both the combustion air and circulating air blower wheels. The assembly is sealed, so there's no passage of air between the two systems. There are two relays on the furnace, one for the furnace blower, the other for the auxiliary blower. When the thermostat contacts close, calling for heat, both relays are energized immediately. A sail switch in the bottom of the blower assembly responds to the flow of air generated by the blower. When the switch closes in response to airflow, the solenoid valve opens, gas flows to the burners, and ignition occurs. If for any reason the airflow is not sufficient, the switch won't close. The control module, also called an igniter board, develops the high voltage current for spark ignition and controls current flow to the gas solenoid valve. During the furnace start cycle, if a flame is not established within 15 seconds, the control module will close the solenoid valve. If the flame should go out during normal operation, the control module will provide one retry for ignition, then close the solenoid valve. The spark for ignition occurs between the spark and ground electrodes of the igniter assembly. The flame-sensing electrode detects the presence or absence of a burner flame, sending a microamp current signal to the control module. Now let's look at the electrical sequence of events when the furnace is started. When the thermostat contacts close, calling for heat, both blower relays are energized and both blowers begin to run. When the furnace blower comes up to speed, this takes only a second or two, the sail switch closes and current flows through the limit switch to the control module. This signals the control module to open the solenoid valve and deliver the high voltage current to the igniter. Once the burner flame is established, current to the igniter ceases. After a minute or so, you'll hear the snap as the fan switch heats up and closes. This provides a second path of current flow to the furnace blower motor. The furnace will continue to run in this mode until the thermostat is satisfied or turned down to a lower setting. When this happens, current flow to the solenoid stops, the valve closes, and the burner flame goes out. The auxiliary blower shuts down. With the fan switch closed, the furnace blower continues to run. It shuts down when the switch cools and the switch contacts open. The furnace is now shut down until the thermostat again calls for heat. Now let's go through the furnace startup procedure. First, turn the thermostat and furnace gas valve off. Wait 5 minutes for any LP gas fumes in the combustion chamber to dissipate. Now, check that the valve on the LP supply tank and the manual valve on top of the furnace are fully open. Open the furnace gas valve and set the thermostat at a temperature calling for heat and turn the thermostat switch on. Look for a flame in the furnace viewport. If a flame isn't established within 15 seconds, the control module will close the gas solenoid valve. If the burner does not light, turn the thermostat switch off. Wait 15 seconds, then try it again by turning the thermostat switch on again. If the furnace won't ignite after 3 tries, you'll have to do some troubleshooting to determine the cause. It's best to begin your trouble diagnosis by making sure of 2 things. First, that you've got adequate electrical power, 12 volts ideally, a minimum of 9. Second, that you've got sufficient gas pressure at the furnace, between 10.5 and 11.5 inches. If voltage is down, recharge the battery or connect to shore power. If you've got no power at all, check the fuse in the living area fuse block and the one in the furnace. Both are 15 amps. If fuses blow repeatedly, look for a short in the furnace electrical system or possibly a burned-out blower motor. Further trouble diagnosis should be based on observations made while attempting to start the furnace. Does the furnace blower operate? Is there a spark at the igniter? Is LP gas entering the burner? The furnace startup cycle begins with the blower. It must start and be up to speed before gas is admitted to the burner and ignition takes place. If the blower does not start, check the furnace blower relay. You'll have to remove the combustion chamber assembly from the vehicle to replace it. We'll cover that and other component removal procedures a little later. If the blower operates properly, the next question is whether or not there's a spark at the igniter during startup. You should see a bright, continuous spark through the sight glass. If there's no spark, check for voltage through the sales switch circuit to the control module during the startup cycle. If there's no voltage, look for a faulty sales switch. Keep in mind that the blower must generate sufficient airflow to close the switch. Look for obstructions to the airflow that might keep the switch from closing. Also, check continuity through the limit switch, which is in series with the sales switch. Check for an open or short in the high voltage lead to the igniter. If it's okay, examine the igniter itself. Look for a poor ground, an incorrect gap between the igniter electrodes, or a cracked ceramic insulator. The only remaining reason why you're not getting an ignition spark is a faulty control module. There's no way you can test it, so try operating the furnace with a new module installed. Don't discard the old one until you're sure it's defective. If you get a spark at the igniter, but no flame is established, you've got to assume that gas is not reaching the burners through the solenoid valve. Check for voltage to the valve during the startup cycle. If you have 12 volts to the valve and it doesn't open, replace the valve. If there's no voltage to the valve, try operating the furnace with a new control module. If the furnace ignites but shuts down after just a few seconds, first check for a loose furnace ground wire. Secure the green grounding wire to the ground screw near the blower relays. On early furnaces, the wire is grounded in the furnace junction box. Next, check for loose mounting screws on the burner assembly. If the furnace shuts down randomly during the duty cycle, the fault is likely the flame sensor. Check the black lead to the flame sensor for continuity. Check the sensor electrode for proper position. The tip must be in the furnace flame. The current should be 5 to 15 microamps through the lead when the tip is properly positioned. A random shutdown can also be caused by air in the LP gas supply or a frozen regulator. Procedures for servicing the LP gas supply system are in your motorhome service manual. These components, the gas valve, gas solenoid valve, and the limit switch, can be checked and replaced without removing the combustion chamber assembly from the vehicle. Removal and replacement of these parts is fairly simple, so we won't go into detail here. To replace other components, you'll have to remove the combustion chamber. Prior to removing any component, be certain the LP gas supply is shut off at the supply tank and you've removed the furnace fuse. Also, beware of sharp sheet metal whenever you're servicing the furnace. To remove the combustion chamber assembly, shut off the manual gas valve at the top of the furnace and then remove the front tow board. Disconnect the gas line lower fitting from the gas valve. Then, loosen the upper fitting at the manual valve. Rotate the gas line 90 degrees so it won't interfere when you pull the combustion chamber out. After separating the furnace wiring from the vehicle wiring, pull the grommet and furnace wiring out of the junction box. Remove the 2 mounting screws and pull the combustion chamber assembly out of the furnace casing. Later, when you are ready to reinstall the combustion chamber, you'll find it easier if you remove the outside vent caps. Otherwise, reinstalling the combustion chamber is just the reverse of the removal procedure. The fan switch is on the right side of the warm air housing. Disconnect the electrical leads and take out the 2 mounting screws to remove it. You'll recall this is the switch that allows the blower to keep running for a time after the burner shuts down. Check the condition of the contacts, which should be open at room temperature. Removal of the sail switch is also just a matter of disconnecting the electrical leads and removing 2 mounting screws. Take care not to damage it when pulling it out of the bottom of the blower housing. Take care, too, when reinstalling this switch. Be sure the sail arm does not contact the sheet metal of the blower housing. To remove either of the blower relays, first remove these 2 mounting panel screws. Carefully raise the panel to give you access to the screws underneath holding the relays in position. Tag the electrical leads when removing either relay. When reinstalling a relay and the panel, be sure the panel engages the mounting tab. To replace the furnace control module, remove the shoulder bolt at the bottom, the mounting screw in each corner, the electrical connector, and the high voltage lead. To remove the igniter assembly, first disconnect the high voltage lead and the flame sensing lead. Remove the plate around the high voltage terminal, the manifold bracket, and both gaskets. Remove the sight glass and gasket. Now remove the front cover screws and the front cover. This gives you access to the igniter mounting screws. Take care that the igniter electrodes clear the burner orifices during removal. Move the igniter assembly to the right and tilt upward to remove it from the burner cover. Before reinstalling the igniter, you'll want to check the spark gap. It should be 1/8 of an inch plus or minus a 32nd. When reinstalling the front cover, be sure the flame sensing lead is properly located next to the main burner gas line. Check the combustion chamber for accumulated soot if you're removing the burners. If there's a lot of soot, you'll want to check for excessively high LP gas pressure. This is usually the cause, since there's no air adjustment on this furnace. Whenever the burners are removed, check the orifices for obstructions. They can be cleaned with a wooden toothpick. To remove the blower motor, first remove the sail switch from the bottom of the blower assembly. Disconnect the motor electrical leads and the flexible air duct from the blower. When you remove the 3 blower mounting screws, you can lift the blower assembly out of the furnace. Remove the outer combustion air housing and the metal plate between the inner and outer housings by removing the 2 attaching screws. Use a 5/64 Allen wrench to remove the combustion air blower wheel. 2 nuts retain the inner housing to the blower motor. Loosen the recirculating air blower wheel with an 1/8" Allen wrench. Remove 3 retaining screws to allow removal of the motor. The motor, incidentally, is sealed and requires no periodic lubrication. With the motor removed, you can then take the recirculating air blower wheel out of the housing. When reassembling, be sure to place the motor with the electrical leads facing the blower housing mounting flange. Check that the recirculating air blower wheel clears both sides of the housing. Also, be sure the retaining screw is tightened onto the flat surface of the motor shaft. Check the inner combustion air housing for proper position in relation to the blower housing as shown here. Here's one final maintenance tip. It's important that the furnace compartment be kept clean to maintain furnace efficiency. Routine cleaning and inspection is recommended once a year. Review this film and refer to the dealer bulletin on the subject whenever you're called on to service a DUO-THERM furnace.